EF Core 10 is finally here, and it brings a lot of solid improvements that can make your life way easier when you're working with the EF Core. Now you can have the full native JSON support. Vector search and vector types, you can use the named query filters and the LeftJoin and RightJoin inside of your Linku queries, and as well the ExecuteUpdateAsync now accepts the normal lambda. And in today's tutorial, we're gonna go through each one of those features inside of the real .NET application. If you haven't subscribed my channel yet, I highly recommend to smash the subscribe button down below, to write the comment, to give me a like, and now let's get started. Today's tutorial is sponsored by the ZZZ Projects, a company that builds some of the most practical and battle-tested tools for .NET developers working with the databases. If you used EF Core or Dapper before in the real production environment, you know how quickly performance can become a problem, especially when you're dealing with thousands or millions of records. ZZZ Projects solves exactly that. Their tools like anti-framework extensions, bulk insert, update, delete, audit, and Dapper Plus can speed up heavy data operations by orders of magnitude and give you features that EF Core and Dapper simply doesn't offer out of the box. What I really like is that these tools aren't just nice to have, they actually save time, reduce boilerplate, and remove a lot of the pain points you hit when scaling your application. If you're building anything data heavy in .NET and you want better performance without rewriting half of your codebase, definitely check out the link in the description and the pinned comment down below. Before we start, we're gonna go through the list of Nuget packages that I have installed in my application to be able to use all of the new EF Core 10 features. So, as you see on the screen, we have the OpenAI, Extensions AI, and AI OpenAI Nuget packages that will be required for you to use the Azure OpenAI generation of the vectors for the vector search. But we'll discuss that more deeper when we'll dive into the vector search. You need also the design and SQL Server with the version 10 to be able to properly assign the DB context and to be able, of course, to generate and update the database based on the migration. Then in the domain layer, where I have my entities, I have the one Nuget package SQL client. It will be required to be able to use the SQL vector type that will be the representation of our vectors. So this will be needed in the following version. And in the persistence layer, we have 3 related to the EF Core Nuget packages with at least a version of 10. Alright guys, so at first I'm gonna explain what application I have prepared for this tutorial, and then we'll dive deeper into the features from the EF Core 10. So, as you see on the screen, we have the DB context already created with the author, book, and blog post entities. Authors with the books are associated with the foreign key, so the author has the list of the books, has also some of the properties that will be mapped to the database columns inside of the table, and we have the book attributes will serve for us the JSON column in our database that will be binded into the book entity. We have also the blog post, and blog post consists only of 2 of the properties, so content and is deleted. And content will be like the content for the whole blog post. And this blog post will use to perform the vector search, and we'll use the Azure OpenAI to be able to generate the specific marker that then our mechanism will use in order to properly filter the blog post based on the text that we'll provide in the endpoint. So the first feature that we'll focus on will be the native JSON support in the EF Core 10. So as you see, we have the book and the book attributes, and book attributes has inside of that couple of the properties, and we would like to use that book attributes and mark as the JSON column. So how we can approach that? So in the DB context itself, we can, in the onModel creating, write as follows. So model builder dot entity, and it will be in this case book, and we have to type dot complex property, and then in the lambda expression, we'll mark the attributes, and then it's gonna be to JSON method. I have inserted the data to the database, so as you see, the attributes column properly handles the JSON content, and in the program CS, we can take advantage of that column, and we can use that in order to filter the books based on the specific attribute from this JSON content that was saved to the database. So now I'm gonna write var query is equal to await context dot books, and then where attributes dot pages will be more than 300, for instance, and then to list async, I will return results.ok and query. In this case, we'll directly filter those books based on the JSON column, so directly in this specific manner. So now I will run the application and we'll check how it will go. And now I will use this endpoint, so I'll run the get request, and we see that we have 6 books that will match our specific filtering. So we can see that those books were filtered correctly. We have the books with the more than 300 pages. So once we have set up the JSON column, now we can move to the LeftJoin and the RightJoin. So as you can see on the screen, we have the books and authors tables, and we would like to join those 2 tables based on the author ID. So this ID has to match with the author ID as the foreign key that is defined in the books table. So now I will write down the following statement. So in order to perform the LeftJoin between 2 tables, you need to at first define the primary table and then to pass the second table as the parameter, after using, of course, the LeftJoin method. So now I will write var query is equal to await context dot authors as the primary table, and then LeftJoin, and as the parameter we'll pass the second table, so the one that will be on the right side. So it will be the context dot books. Then we need to use the author ID as the ID of the left table, and book dot author ID as the foreign key in the books table, so the table on the right side. And then we'll use the projection, so author and the book. And now we can use the, for instance, author name and the book title from those 2 tables. So it will be the author name and the book dot title, and at the end to list async, and then return results dot ok and the query. And now we'll implement as well the RightJoin. So I will copy the content of that. I'm gonna paste it down here, and we would like to perform the RightJoin. So we need to return all the rows from the right table and only the matching ones from the left table. So as before, the primary will be the authors, but then it will be the RightJoin, and everything will remain the same. So in this meaning, the primary table will be the authors, but this books table will be marked as the right table. So everything from the table on the right side, and then only the matching rows from the left side. As you can see, here we have also the reference of a possibly null reference, but of course we would like to have the nulls in case of having no matching element. So in this case, this is valid at this point. So in this left join, we are defining left join and we are passing the right table here as well. But as you can see also here, that the reference of a possibly null reference is down here and here on the outer side. So it means that in this left join, we are returning everything from the authors table and only the matching elements from the books table on the right side. And in the right join, we are doing the opposite. So we are getting everything from the books table and only the matching elements from the authors table. And now we'll execute the following HTTP request, so left join authors. And now as the result, we can see all the authors with the book titles. And down below, we can see also the author without books 1 and 2. So the title in this case will be null. So we have all the authors and only the books that match with the authors, because this is the left table. And in case of having no matching elements, we have the nulls. And now I'll execute another endpoint, and we see that we have the name as the author and the title. So everything seems to be completely the same, but as you see, we have also the orphan books, orphan book without an author. So it will be retrieved, but the name of the author will be null in this case. So it identifies that we performed the right join. And now the vector search in the EF Core 10. So EF Core 10 allows you to use the vector data type in the SQL Server and the Azure SQL. So if you're using the SQL Server locally, then you have to update to the version 2025. So what is the vector? So it's basically the high dimensional numeric representation of something. So it could be the text embedding or an image embedding. So when we generate an embedding from the piece of text, we get a list of numbers. So this vector captures the semantic meaning of the text. So two pieces of the content that are similar in meaning will have the similar vectors. So the EF Core lets us to store these vectors directly in the database using the SQL vector of the type float in the C#. All right, so we're gonna concentrate on the blog post and the content of it. So we're gonna simulate the scenario of searching for the specific blog post based on its meaning. So we'll have the request that will send to our minimal API endpoint, and then based on the content, it will generate the vector and check for the similarity based on the already existing blog post in our database. So now I'm gonna introduce the vector. So it will be the public SQL vector of the type float, and it will be called vector get set, and we'll use the data annotations. So it will be the column of the type name, and the type will be the vector of the following dimensions. And as I have said in the introduction of this tutorial, we're going to use here the Azure OpenAI to be able to generate the embeddings, so meaning the SQL vectors, so the similarities for the specific blog post. So this is the working example of the very simple configuration for getting the embedding generator. So you can use that code if you would like to little bit experiment with the Azure OpenAI. So this generator then will be used to generate the vector based on the specific string of the blog post. So we are getting the endpoint, API key, and the deployment name based on my appsettings.json file, and we are creating the Azure OpenAI client, and then get embedding client based on the deployment name, and deployment name will be the specific deployment for getting the embeddings in the larger size, so then it will represent the specific vector with this dimension. I will only add here that to let you know which model I have used. So it will be this deployment name, so text embedding 3 large from the Azure Open AI. Now I will implement two endpoints. The first one to create a blog post based on the request. So here we need to generate the vector based on the content of the blog post and then save to the database, and the vector search endpoint to get from the request the search param, and this parameter has to be converted to the vector, and then anti-framework core will compare based on the similarity which one is the most similar to the text that we have provided, and then we'll perform the order by, so based on that similarity, and we'll take 3 of those. So the first one will be the map post endpoint. And now I will type as follows. So var vector, because we need to generate the vector, it will be equal to the new SQL vector of the type float. And inside of it, we'll use the following function. So it will be await embedding generator dot generate vector async method. We need to provide from the create blog post request the text, so it will be the request.content, and the second parameter will be the new embedding generation options, and here we'll assign one parameter, so it will be dimensions will be equal to 1, 5, 3, 6. So it's associated with the model that we are using to generate the vectors, and as well this is the same as we have defined over there, so in the blog post, so it's the specific type of that dimension. So now once we have the vector, we can use await context dot blog posts at async new blog post, and inside of it we'll assign the content, so request.content, and the vector is equal to the vector. I'll of course use the context dot save changes async method, and then we'll just return the OK result at the end. And now I will implement the vector search endpoint. So I'm going to replace this with the following parameters. So we'll take the request, another one, so the blog post search request with the search text inside of it, context, and also the embedding generator. Now we need to create the vector based on our request search text, because we would like to search for the blog post with some kind of value, so we need to generate the vector based on this text. And now we need to use the vector distance function from the EF core functions to be able to check the similarity between this vector and the vectors of each blog post, and then order by this similarity. So I'm gonna type var blog posts is equal to the await context blog posts order by, and we'll use the following function. So it will be the ef.functions.vector distance, and the first parameter has to be the similarity. So we'll use the most efficient one, that is called cosine. Then we'll pass the parameter of the vector inside of those blog posts, and then the vector that we would like to compare with, so the vector from the blog post search request. Then we'll take 3 of those blog posts and then to list async. And at the end, I will return the results.ok, but not the blog post, but we'll use the blog post to generate the list of only the contents. The vectors are very heavy in terms of the response, so I will pick only the content from those blog posts. I have my API up running, so now we can check how the workflow looks like, so we can debug those two endpoints. So now I will send the request to create the blog post. So it will be cooking tips for pasta and sauces. So I'll run this request. And as you see, based on the request.content, we have generated the SQL vector. So this vector was generated by the Azure OpenAI. So this generate vector async provided us the vector. And as you see in the database, it looks like this. So this is our vector. And based on this vector, then we'll retrieve the blog posts. So we'll generate the vector based on our search param, and we'll compare our vector based on the search param with the vector in the database. So now I will generate more of those blog posts. I have a couple of requests prepared. I have created 10 of the blog posts based on the categories. So we have cooking related stuff and also the database / EF core blog posts. So now I'm going to search for the top 3 related to the pizza. So now the search text will be pizza. I'll send the request. And as we can see on the top, we have the content, article about cooking the best pizza in the universe, content, the best Italian dishes, and then Polish food, best dishes that you can eat. And when we'll change this with, for instance, EF core, and we'll send this request, we can see that on the top we have how to use EF core 10 vector columns to rank blog posts, then a deep dive into embeddings for the semantic search, and then introduction to vector databases and cosine similarity. So as you can see, that algorithm to check the content based on the vectors is very, very efficient. Now let's talk about the huge improvement of the already existing query filters that were introduced in the later versions of the EF Core, but now in the .NET 10 and the EF Core 10, we are able to define more than one query filter, so it makes the way simple to, for instance, append the filter for the multi-tenancy or the soft deletion filter as well to one specific entity. Before it was not possible to do that. So now I would like to introduce the 2 query filters for the author entity. So it will be the soft deletion filter and the verified filter. So it will look as follows. So model builder entity author and then has query filter. Then you pass the name and the logic behind it. And has query filter, another one when the author will be verified. So for now, those 2 query filters will be applied automatically when using the authors with the DB context, and we can also ignore them if it will be needed. So in this endpoint, I would like to return results.ok and await context.authors.include, it will be books, and to list async. So in this case, those 2 query filters will be applied. And if you would like to ignore the query filters, you can do as follows. So you can use the ignore query filters method. So over there, I'll type ignore query filters, and here in the array, you can pass the names of those query filters. So in my case, it will be the soft delete filter. and as well the verified filter. So in that case, I will be able to retrieve all the authors and to not use those query filters. After sending the request to the first endpoint to just get the authors as is based on the query filters, we can see that we have only the authors with the isDeleted set to false and isVerified set to true. And now we would like to disable those filters and get the authors without having those filters applied. And now I can see that, for instance, this author has isDeleted to false, but isVerified to false, and it was retrieved from the database. So it means that those query filters were disabled, and we can very easily disable them, in this case with the usage of only one method, and specify their names. So now let's go through the ExecuteUpdateAsync method enhancements in the EF Core 10. So now we are able to pass the lambda expression to the ExecuteUpdateAsync method. So I'm gonna write down context.books.where attributes with the pages more than 300, more than equal than 300. If it will match, then I would like to update the title of this book and add the long read in the parentheses. So now I will use ExecuteUpdateAsync method. And in here, we'll pass the lambda expression. So we'll set the property, and it will be the book.title. And as the second parameter, it will be b.title and plus long read. So in this case, we'll be able to very easily update the set of books based on the filtered collection. So now I'll run the API and we'll update all of those. And now I will execute the following HTTP request. We've received 200 OK response, and after performing the request, we see that only the books with the pages more or equal to 300 were properly updated with the long read additional text to their title. Alright guys, so this is the end of this tutorial. If you haven't subscribed my channel yet, I highly recommend to smash the subscribe button down below, to give me a like, to write the comment down below, and see you in the next tutorial.